out the light ends. And as we've seen previously, we have ignored this little section on the input data. But why do we ignore it? Well, because light ends are very special. They are modeled with pure components. They have low boiling points. So examples of these will be ethane, propane, propylene, butanes, isopentanes, cyclopentanes, and so on. So this is the light ends. They are, let's say, this is a very special because they are typically gases, found as gases in our crude oil, or maybe very volatile material. And instead of actually using hypocomponents, HYSYS recommends us to use the actual values of the pure substances in the existing databases. So as stated here, use discrete pure components. Why would you want to use a hypocomponent if you have already a substance known and existing in the library, and yet we can characterize it? It is easy to characterize it in a lab. So that's why we have this option to add light ends. Now, we have three options when modeling light ends. The first one, which we have been doing in the previous workshops, is to ignore them. Assume that our feed is only liquid and solids mostly, or the crude oil does not contain gas. So we have assumed that the gas is gone, and we only consider this right here. Of course, this is not true in real life. We still have some vapors inside the crude oil, but we have been ignoring them. Now, the most desired and the, let's say, the most typical will be to actually input the composition of the light ends. When you have a crude oil assay, they will send you all the light composition. They will tell you the C2 up to C5 composition, and then they will say, well, C6 and C7 plus and so on. They will treat them as we have been doing as assays. But this is discrete data, so you can and we will input it in our specification. Now, the worst case scenario will be to know that we have the gases. So we got our oil here, and we know it has some gas, yet we don't have the input composition. So the good thing is that HYSYS can still auto-calculate it based on the composition of this part right here, the liquid and the solids. So Aspen will extrapolate the data and will be able to model, or theoretically model, make a model fit of the light ends. As stated before, light ends will be methane, ethane, propane, butanes, and maybe even pentanes. Now, a very important tips before we actually go into the workshops will be ensure that the light ends are included or not. So this is very important because if we know that they are not included, we must choose ignore. And if we know that they must be included and we don't have the specifications, we must choose auto-calculate. And if we have the specifications, we must input the data. Okay, so just be sure whenever you get your data, check out if you have the input of the light ends or if you don't have them. Okay, so let's check out the workshop, guys. This is pretty similar to what we have been doing before, but we are going to add just the light ends. And the important part right here is that the results will be pretty similar. They are just going to include the light ends as well.